Bismillahirrahmanirrahim. Sallallahu alaihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wasallam. The Modulus Functions, Lecture 3. Topic. Today's topic is the solution of modulus inequalities by graphical method. Since this topic was added in the syllabus in 2020, therefore you need to solve the questions of square method to this graphical method as well. Examples or types of questions. The following are the example of questions which can be solved by this graphical method. Now let's discuss the graph of modulus functions. The graph of modulus function is a V-shaped graph with vertex that is the turning point at V00. Since modulus x is basically plus minus x, therefore we have two parts of the graph. Y is equal to positive x and y equals to negative x. This negative part is basically the reflection of the negative part of the graph. For modulus we need to reflect this part about the x-axis. Therefore for modulus x, you need to reflect the negative part about the x-axis. So here are some important points regarding the modulus and sketch. For modulus, we reflect the negative part of the graph about the x-axis. This is very important because modulus converts the negative into positive. Here, this is the negative part. So for modulus, we just need to reflect this part about the x-axis, and this is the resultant part. This is the part which is after the reflection. Point number 2, you should also, you need to label the axis and label the intercepts. This is very important regarding the sketch. Let's do an example to understand modulus part in detail. In this example, we have to sketch y is equal to modulus x minus 3. In order to sketch this graph, we need to sketch y is equal to x minus 3 first. And then we will reflect the negative part about the x-axis for the modulus thing. Now let's sketch y is equal to x minus 3. To sketch any line, in general, we need at least two values of x and y. The most important values are intercept values. I'm taking intercept values in this case because the intercepts values make the sketch simple. We will first sketch y is equal to x minus 3 and we will sketch the negative part by means of broken line. Here is the negative part which will be reflected about the x-axis. Therefore, after the reflection, 0 minus 3 will become 0, 3. I will sketch this reflected part with in red color. Here is the negative part of the graph. This negative part has been reflected about the x-axis, and this is the resultant graph. And that's the final answer of this sketch. Now let's do one question regarding the modulus. Example number 1. We have to solve this inequality by graphical method. First, we will sketch this graph in green color, and then we will sketch 2x minus 3 in different color. Let's sketch y is equal to x minus 2 first. This is the sketch of y is equal to x minus 2. Now for modulus, we will reflect this negative part about the x-axis as. Here is the final sketch. We have two parts. This is the positive part because this line has positive gradient, and this is the negative part because this line has negative gradient. Now we have to sketch the second graph, which is y is equal to 2x minus 3. I'm using purple color to sketch y is equal to 2x minus 3. I've got the point. The first point is 0 and minus 3, which is here. And the second point is 0 and 1.5, which should be here. 1.5 and 0. Now I have to sketch this line. This is the sketch of y is equal to 2x minus 3. and there is only one intersection point which is labeled as A. To get this value of x, we need to solve this 2x minus 3 with this minus x minus 2 equation. Here we'll solve this equation. Therefore, the x coordinate of the point of intersection is 5/3. Now we have to write the solution, and that which is the most important part of this question. For that, we need to observe where the graph, in fact the green graph is above the red graph or purple graph. That is, the green graph is above the purple graph. We have to find that region. If we go to the left side from the x coordinate of turning point, we will observe that the green graph is above the purple graph, and therefore the solution would be x less than 5/3. I mean, if we go on the left side from the x coordinate of turning point, then we observe that green graph, this green part, is above the purple part. So this is the right solution, and this question is over. Now let's discuss one more example of this graphical method. In this question, we have both sided modulus. Now we will sketch both the graphs one by one. Let's sketch 2x minus 1 graph first in green color. Therefore, this is the graph of y is equal to 2x minus 1. Now for modulus, we will reflect this negative part about the x-axis. Since this point has coordinates 0 and minus 1, therefore after the reflection, it will become 0, 1. Therefore, this is the final sketch of this modulus graph. Now, this is the negative part of the graph, 2x minus 1, because this line has negative gradient. And this is the positive part of the graph, because this line has positive gradient. And this is the vertex, it's 0.5, 0. Now let's sketch the next graph, which is 3 minus x in purple color. Now that's the graph of y is equal to 3 minus x. Now for modulus, we will reflect this part of the graph about the x-axis as. Now that's the final sketch of this y is equal to 3 minus x modulus. Now this line has positive gradient. Therefore this should be x minus 3. And this line has negative gradient, therefore this part would be 3 minus x. Now there are 2 points of intersections. This is, let's suppose, A, and the other point of intersection can be labeled by B. Now to get the x coordinates of both the point of intersection, we need to solve these two equations and this equation with this equation. Let's solve the equations for the x coordinates of A and B. At A, the line y is equal to minus 2x minus 1 intersects the line y is equal to 3 minus x. Therefore, x coordinate of A would be minus 2. Now, let's work for the x coordinate of point B. Hence, the x coordinate of point B is 4/3. To solve the inequality, we must find where the graph of the function 2x minus 1 modulus is above the graph of modulus 3x minus x. Let's find where the green graph is above the purple graph. So if we go towards the left side from this point of intersection A, then we find the region where this green graph is greater than or above the purple graph. So according to this sketch, we can say when x is less than -2, in fact less than equal to -2, then green graph is above the purple graph. Now with respect to point of intersection B, if we go to the right side of this point of intersection from 4/3, this is 4/3, then we observe that green graph is above the purple graph. So according to this sketch, or according to this situation, we can say when x is greater equal to 4/3, then the green graph is above the purple graph. So that's the solution of this inequality. Hence the answer is x is either less than equal to -2 or x is greater equal to 4/3. Now that's it, this topic is over. You should practice most of the question. We will discuss properties of modulus inequalities in the next lecture, inshallah. Allah Hafiz.